Gas law constant lab. So this will be the actual experiment that we're going to have. And I don't know if you can see this. This is a piece of magnesium. It's maybe 3, maybe 4 centimeters. Okay. And I weighed this and it weighs 0.066 grams. All right. And what I'm going to do is I'm going to take that and I'm going to get that wrapped around that magnesium. It's going to be reacted with some hydrochloric acid, but I'm going to wrap this up in a little cage here. And I have a rubber stopper with a piece of copper wire on it. Copper wire will not react with hydrochloric acid, but the magnesium will. And what I don't want the magnesium to do is to get all away from me. So what I'm going to try to do is hold it in place for a while so it doesn't float up to the top. Eventually it is going to float up to the top. I realize it, and I'm going to hold it down so that the hydrochloric acid can be with it enough so that I completely use up the magnesium. So I want to completely react all the magnesium there. And you know what? I think that's going to be good enough right there. Another thing that it asked me to do is, let's see. So I got my magnesium, I rolled it up, and I encased it in copper wire. Then I'm going to add about 15 milliliters of hydrochloric acid, which I'm going to have extra of it because I'm going to use up all the magnesium. So it's going to be extra. So I'm not really too worried about it. And I can just look at it here. Looks like it's gone up to about the 14. So I'm good with that. There's going to be enough there. So this is a hydrochloric acid in here. And then what I'm going to do is I'm going to add water to this. Okay. And it should be room temperature water, which I have right here. Maybe I'll just use the funnel and add it like this. I'm going to fill this up to the brim. Okay, and that's pretty good. I don't want to have any air bubbles in there, or I guess you could say air bubbles. So I'm going to top it off a little bit right here. I'm just grabbing some water here. You top this off. A little bit of water might spill over the side. Okay, that looks pretty good. Just slowly fill the rest of the tube to the brim and then insert the cage magnesium a few centimeters in here. So I'm going to grab this. There's the magnesium. It's on the copper wire. And I'm going to put this on. It's probably going to cause a little spillage down the side, but I don't care. That's just water. Okay, and it's dripping down there. And then what it says is cover the hole with the finger and invert this into a 400 milliliter beaker right here. So I have this beaker right here. I'll hold that back here so you can still see it. And I'm going to take this. Remember the hydrochloric acid is on the bottom. I'm going to take this and flip it so I don't get any air in there and do that. You might see a tiny bubble go up, but pretty much not anything moving right there. So I'm going to keep this right here. Now I could balance it back in this thing, which I probably will do. Okay, so I don't have to hold it, but I don't want to raise that level right above. So I don't think you can see this back where you are, but what happens is this hydrochloric acid is more dense, and you can kind of see these little convection lines, and they are going down as the hydrochloric acid sinks. And now ultimately, that hydrochloric acid will sink down, hit the magnesium, and then hopefully it will do the reaction. Remember, the magnesium is going to react with hydrochloric acid to create hydrogen gas, which will bubble up into here. So we'll be seeing that happening probably in a couple minutes. Maybe get that a little closer and then see that there. But there's nothing really happening right here. You're seeing this process, and that's what's going on. Get a little closer. Bring this in a little closer. And now what happens is, it's just starting to hit. I don't know if you can see that well, and I'm getting a little bit of fizzing right here, but not much. Okay, so there's a little bit of effervescence as the first hydrochloric acid reaches it, and there's some bubbles going on there. And it's still pretty small, but now they're starting to go. If up here, how much gas have I collected? Maybe a milliliter. So it's not really bubbling much. And I'm trying to see if I can give you a backdrop that might help that, a darker backdrop perhaps. The gas being collected, that may or may not help. White backdrop might work. Okay, now it's kind of getting quite sparkly and bubbling, but still I've only collected maybe 2 milliliters of gas. So even though it looks like it's effervescing, I haven't collected too much yet. So we're just going to kind of keep this thing going. And I don't know if that helps you see things. Got about maybe up to there is where the gas is. So these bubbles are coming up, going through, and I'm down to about here, maybe 4 milliliters of gas. And this is 100 milliliter tube. So we're going to try to keep this going. Now it's quite a bit of bubbles. You can see that well. We'll kind of bring the computer closer, a little bit more of an up close. And again, you can start to see those bubbles coming up there. And yeah, so you can see those bubbles definitely coming up. Almost looks like a helix, like a fire coming up and a little thing there. And that's coming from the bottom. So I think you get a better idea of that. Move that back here. Come back here a little bit so you can still see. Keep that adjusted. We slide that back here. And this goes, it's probably going to take about, by the time I start, probably about 5 minutes for it to completely react. So it starts out slow, goes really fast, and then it'll kind of dissipate toward the end here. And maybe just a couple numbers of data that you should be getting. See, if you look at your data table, there are some pieces of data. So I think I'll give you that right now. The mass of the magnesium is 0.066 grams. The volume of hydrogen gas, we haven't figured it out. Right now, we're at about 50 milliliters. It's still going strong. The room temperature is 20.0 degrees. Okay, use the thermometer here. You'll see right in there. That's what I used. And but I read that as 20.0. But you're going to need to convert that to Kelvin. And then another thing was the atmospheric pressure. And we're assuming this gets equalized to atmospheric pressure, which looks like it's about 759 millimeters mercury. A little device there that I'm kind of talking about right here, looking at that needle. And I had that as 759 millimeters mercury, kind of going with that middle scale right there. I'm looking at this, and we are almost done reacting this right here. So I'm not quite to the finish, but I'm going to look at this. There's a little magnesium that dislodged and went up here. It's almost all reacted. All these little bubbles, I want to kind of nudge them and get rid of those, because those are part of the thing. If I don't include those are all reacted hydrogen gas, and they're floating up to the top. So just looking at this, I'm thinking, sorry, I'm kind of blocking this so you can't see it. It looks like it's somewhere between 72 and 74 milliliters. And for I would typically let this, it probably warmed up a little bit. So I'd let this come to room temperature, and then I would actually take the reading. But I'm just going to go with this reading right now. And then we have it right here. I'm going to call this 73.4 milliliters. Okay, so I'm going to call it 73.4 milliliters. And then you can record that right there for the volume of the gas. That is in milliliters. What we have. So I think that gives you a pretty good idea of the demonstration of what's happening. And now I'm going to take this and use this data and process it. Take the other video and it gives some hints about the processing data. This is kind of just a video to see what we did in lab and then matching it up with some sample data. I'm just going to come over here and look over my shoulder. And I think you can see some things here. Let's see what we got. Do this right. Mass of magnesium. I don't know if this is showing backwards or not. Mass of magnesium is 0.066. The volume of H2 gas is the volume of H2O gas is 73.4 milliliters. The room temperature is 20 degrees. Okay, so we just estimated there, and that's fine. And then the room pressure is 759 millimeters mercury. That might be backwards, it might not. I can't remember how that looks, but those are the figures. I'll read them again. 0.066 grams of mass of magnesium, volume of hydrogen gas and water vapor combined, 73.4 milliliters. Room temperature is 20 degrees Celsius, and room pressure is 759 millimeters mercury. The vapor pressure of the H2O inside, you can just get that vapor in the tube. You'll get that from that data table. All right, I think I'm going to sign off on this experiment, and thanks for watching. Let me know if you have questions. Thank you.